Contrary to general perception that plastics are highly difficult to degrade or recycle, it has now been shown that fiberglass composite products can be recycled with ease. This makes these products to be listed among those that generate low carbon footprint, which in turn supports the environmental conservation. This lecture briefly dwells upon this fact deduced through mathematical modeling while assessing life cycle LCA of fiberglass items. Composites can be easily recycled. Recycling of composites makes business sense and it is environmentally beneficial. Fiberglass composites have a better ecological footprint than traditional materials like steel, aluminum, and concrete. A representative composite part having stationary application made of different materials was evaluated during the life cycle assessment with useful life expectation of 30 years. To ensure the quality of the LCA study, the results were reviewed by independent experts according to the requirements of international standards ISO 14040 and ISO 14044 standards. A representative composite part having stationary application made of different materials was evaluated during this LCA, for a useful part life with a life expectation of 30 years. Some of the key model assumptions are flashed on the screen. The results clearly show that composites can outperform steel and aluminum when it comes to global warming potential, GWP in kg carbon dioxide, equivalent per functional unit. Graph on the screen represents the outcome of calculations. Recycling of glass fiber reinforced thermosets has been studied extensively with the aim to yield potential waste management solutions. Glass fiber thermoset composite parts, originating from part manufacturing or end-of-life components, are cut in smaller sections and processed into small chunks. The resulting regrind is combined with other feedstock materials into an input stream with consistent composition and caloric value. Co-processing composites through the cement kiln route is considered the best recycling option. Low carbon footprint for fiberglass has been elaborated in preceding slides. Cement production processes can accommodate fiberglass at its end-of-life point in life cycle assessment process. Processing is the simultaneous use of composite regrind as raw material and as a source of energy in cement manufacturing, to replace natural mineral resources during material recycling and fossil fuels such as coal, petroleum and gas, allowing energy recovery. In this process, composites regrind used for co-processing is both an alternative fuel and raw material. The transportation of composite regrind from its source to the cement kiln will obviously influence the calculation of the eco-footprint. However, it has been proved that transportation contributes at a very low percentage in carbon footprint generation. This slide shows the carbon footprint of using recycled fiberglass in production of cement. Depending on the inclusion of quantity of composite regrind and the specific cement plant technology, the reduction can be as high as 16%. All countries around the world, particularly less advanced countries, should follow the steps being taken up by European Composites Industry Association to arrest environmental degradation through sustainable actions in recycling and reuse of fiberglass composites and other daily use products. Aim should be a conscious attempt to reduce carbon footprint for each item produced by industry. Important web links are flashed on the screen. Stay tuned for future courses on offer from Technology Education and Mentoring Center.